Assalamualaikum warahmatullahi wabarakatuh and good day to all panels. I am Muhammad Zakwan bin and today I will be presenting final year project 1 proposal with the title of Fluid Structure Interaction of Blood Flow and Aneurysm. During my research, I was supervised by Dr. Nadia Binti Abdul Latip. My slide contents consist project summary, introduction or background of study, literature review, problem statement and objective, scope and limitation of the project, methodology, and expected result. Fluid structure interaction, or FSI, is a study on the interaction between a deformable structure with the fluid flow surrounding it. This interaction can be investigated using computational simulation by coupling the transient structural solver with the fluent fluid flow solver in ANSYS Workbench software. In this project, an investigation on how a mechanical structure, specifically the wall of an aneurysmatic blood vessel, interact with the blood flowing through it will be conducted. Research studies have used two-way FSI to examine the hemodynamic and biomechanical change that occur during the growth stage of an aortic aneurysm. For background of study, fluid structure interaction studies the combination of computational fluid dynamics (CFD) and finite element analysis (FEA) to investigate fluid and structural behavior, as well as how they interact and impact each other. FSI also demonstrated significantly in several biological tissues and organs such as insect wings, fish fins, human heart valve, and human vocal folds. For biological system that I researched, aneurysm is a disease that caused by an abnormal and permanent bulge or dilation in blood vessels. Generally, it occurs in the aorta artery, cerebral vessels, mesenteric artery, splenic artery, and popliteal artery. Among cardiovascular disease, aortic aneurysm are characterized by the aorta expanding to about 1.5 times from its normal size. An abdominal aortic aneurysm, AAA, usually occurs near the iliac bifurcation, which is abdominal region and is often accompanied by thrombus growth. For literature review, I focus on do some research on previous studies about FSI in cardiovascular system and aneurysm. Amindari et al. Used ANSYS package program to simulate the hemodynamic of the aortic valve. Simultaneous fluid zone and structural zone for this project were created under ANSYS Workbench by using separate solvers. Furthermore, Howe et al. Identified the FSI problem with the arterial wall, which is mainly composed of smooth muscle cells and blood fluid flow. The pressure of the blood flow acts on the inner surface of the arterial wall to deform the aneurysm. In addition, Thoma et al. Analyzed the study of FSI in biomedical applications. Next, Crossetter et al. Simulated on intra-aortic hemodynamics, taking into account the 3D FSI between blood flow and arterial wall by modeling blood as Newtonian fluid and the aortic wall as a structural component of linear elastic structure. Lastly, Philip et al. Conducted a study about an idealized spindle-shaped aneurysm model. A dramatic increase in maximum wall shear stress and wall displacement was observed as the aneurysm approached the critical diameter. For problem statements, in the last decade, the use of fluid structure interaction (FSI) has increased dramatically in cardiovascular engineering since finite element analysis (FEA) and computational fluid dynamics (CFD) are generally insufficient to fully describe the physical modeling of the cardiovascular system. In addition, they cannot resolve the interaction between the solid and fluid domain, where the interaction is integral to the operation and the functioning of the system. The use of FSI methods will control these shortcomings by providing the means for fluid and structural domain coupling. This project also tried to study the relationship between blood flow dynamics and arterial wall mechanics when two-way coupled FSI working. There are two objectives for this project. There are to develop two-way FSI models of blood flow and abdominal aortic aneurysms with different ranging from 4 cm to 7 cm, and secondly, to investigate the effect and interaction between blood flow and the aneurysm with different size on the wall shear stress of the aneurysm. In this project, the main purpose that need to achieve is to analyze the functions of computational fluid dynamics, CFD, and finite element analysis, FEA, in FSI of biological systems. We need to construct and simulate using computational tools such as ANSYS software to achieve the main purpose. Through the simulation, the significant relationship between CFD, FEA, and FSI also can be identified. For methodology section, there are three main parts that I will explain more details later, which are research, simulation, and last but not least, result and analysis. For research part, firstly, I start the project by finding the previous articles that relates to my FYP title. Next, I do some brainstorming section to identify problems for recent project. For simulation part, I will start by design the idealized model of the project by using space clamp in ANSYS software. The figure and table below show idealized abdominal artery aneurysm AAA models and its geometric parameters used in the recent studies. Then, I will do the determination of important geometry in ANSYS software such as wall thickness, diameter of the artery, and properties of abdominal artery aneurysm. The table below shows the properties of abdominal artery aneurysm AAA. For wall thickness, I assume 1.8 mm to all models for simplicity. After finish this step, the simulation of the model will run. After finish run simulation of the model will validate based on the project's objective. Next, I will go for result and analysis section. For result and analysis, I should identify the average of wall shear stress WSS and maximum wall stress in abdominal artery aneurysm that will display in the ANSYS software. I will describe more detail for result and analysis in the expected result section. For expected results, I will explain based on the earlier studies. In the previous study, it is important to analyze the flow characteristics within the affected shape and develop more consistent correlation between hemodynamic parameters and aneurysm rupture characteristics. The most commonly evaluated parameters are wall shear stress, time average wall shear stress, oscillatory shear stress, average wall shear stress, space and time gradient of wall shear stress. So, in the recent study, I tried to investigate the average of wall shear stress and maximum wall stress, which is von Mises. The figures in the right of the slide show the average wall shear stress superimposed with direction of action in the upper side and maximum wall stress on the inner wall of the model aneurysm in previous study on the below side. That's all from me. Thank you and wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.